In this lesson, you will identify direct and inverse variations, and you will also write an inverse variation equation. Remember direct variations from earlier in the year? They're in the form y equals kx. Direct variations are proportional relationships, and they always go through 0, 0 when you graph them. For example, buying pizzas at Little Caesars is a direct variation. It doesn't matter how many you buy, the price per pizza is always $5. It would be a straight line that goes through 0, 0 if you were to graph it. And the equation would be y equals 5x. It's a direct variation, otherwise known as a proportional relationship. Now, inverse variations is different. The time it takes a runner to finish a race is inversely proportional to the average pace of the runner. In the situation above, the runner's time decreases as the pace of the runner increases, so these quantities are inversely proportional. An inverse variation can be represented by the equation y equals k divided by x, or written another way, xy equals k. So y equals k divided by x is an inverse variation, where y equals k times x is a direct variation. Now before we start here, let's just quickly make a little note up here that direct variations, that is really messy. Direct variations are y equals kx, and inverse variations are y equals k divided by x, or in other words, k equals, if you multiplied both sides by x, you would get k equals x times y. Where in this case, if you wanted to figure out what k is, you would divide by x and you would get k equals y divided by x. So now we're going to look at these tables and decide if the representation is an inverse or direct variation. Well, to be an inverse variation, you would multiply x and y together to get your constant, or k. So here, 1 times 16 is 16, 2 times 8 is 16, and 4 times 4 is 16. So that's going to fit your inverse variation. In our next example, 1 times 3 is 3, 2 times 6 is 12, and 3 times 9 is 27. That does not work. But if we take y and divide it by x, 3 divided by 1 is 3, 6 divided by 2 is 3, and 9 divided by 3 is 3. Since that works out, that's going to be a direct variation. Another way to think about this is if you take x and multiply it by a constant, in this case 3, 1 times 3, 2 times 3, 3 times 3, you end up getting y. Now in our next example, if I were to multiply x and y together, I get 10, 10, and 10. Since I'm multiplying x and y together to get k, it's going to be an inverse variation. Now the next type of example is looking at equations to determine whether it is going to be a direct variation or inverse variation. You could think of it as solving both sides or solving it for y to see which one it looks like. If I wanted to solve this for y, I would divide both sides by 2. And I end up with x divided by 2 equals y. Now I could write this another way. I could write this as 1/2 x equals y, which that is a direct variation. Y equals kx. So I would say this one is direct variation. Now for the next one, I would want to divide both sides by 2x to get y by itself. So you end up with y equals, and I can simplify the 10 over 2 to being 5 over 1, or 5 over x. Y equals 5 over x. Y equals 5 over x would be an inverse variation. Now this one, it's already solved for y. Y equals negative 2x. That's in the form of y equals kx, so that one is a direct variation. Now the last thing we're going to do is we're going to write an inverse variation. It says assume that y varies inversely as x. If y equals 18 when x equals 2, write an inverse variation equation that relates x and y. Well, if it varies inversely as x, you would say y equals k divided by x, or in other words, we said k was equal to x times y. We need to figure out what k is. So in this problem, we could either write y equals kx, or k divided by x, and then we would plug in place of y, we would put 18. And we don't know what k is, that's what we're trying to find. And then divide by x, which is 2. Now to solve this for k, you'd multiply both sides by 2, and that would tell you what k is. Or a quicker way to do this is to use this form right here. K equals x times y. So to figure out what k is, it's going to be 2 times 18. Well, 2 times 18 is 36, so k equals 36. Now, once you know what that is, you can either write your equation as xy equals 36, or you could say y equals 36 divided by x. In our next example, it says, assume that y varies inversely as x. If y equals 5 when x equals negative 4, write an inverse variation equation that relates x and y. Well, again, inverse variation is y equals k divided by x, which means k is equal to x times y. So k in this case is going to equal negative 4 times 5. Negative 4 times 5 is negative 20. So k is going to equal negative 20, which means our equation is either going to be xy equals negative 20, or y equals k, which is negative 20, divided by x.